In this video, I am going to go through the first part of the review, and I'm recording from home, so I don't actually have video working. I'm just sharing my screen. So I'm just going to be talking through the problems, and I'm recording this early because class was canceled. So I will be posting this link as a study aid for you to help you go through the review. I'm going to skip the first 8 questions because it's a lot of reading, and I'm just going to let you figure those out on your own. Those are concept questions. Starting with question 9, we are asked to find the amplitude of this function y equals minus 4 sine x. And I should probably check and make sure my share screen looks good. It does look good. Okay. So y equals minus 4 sine x. The amplitude is the constant right here, the absolute value of that constant in front of your trig function. So in this case, it's sine, and the amplitude is 4 because the absolute value of -4 is 4. Here again, we are asked this time to find the period. Now, the way you find the period is you take the period of sine and divide by the constant b. The constant b is the constant in front of the variable. And you can see there is no constant in front of the variable, so that's understood to be 1. And so this is just a plain old sine function. The amplitude is 3, but as far as the period goes, that has not changed. And so the period of the sine and cosine are both 2 pi. And so that is what we have here for the period. Next, the constant in front of the sine is your amplitude, except you're going to take the absolute value of -1/5, and that's 1/5. Here we are asked to graph the sine function, and the sine function passes through the origin, and then it increases and then decreases. So you're going to, let's see, if you look here, it looks like this is the sine function right here. It increases and then passes through pi on the x-axis, and then goes back here to complete 1 period. So that is the correct graph. Sorry about the background noise. I have a large family, so there's a lot going on. I have my door shut, but I think this mic that I have is very sensitive, so you might be hearing that in the background. Okay, graph the function and y equals sine x in the same rectangular system from 0 to 2 pi. Notice the amplitude is 1/2, and the sine function is going to have an amplitude of 1, and so this is going to be 1/2 now. So it looks like this is the correct graph. You notice that the pink is the sine function, and then the blue is the same shape and period and everything. It's just half the height. Let me just pop that out. So here you can see it's the same wave. It's just that it's half the height of the sine function. So looks like A is the correct choice. Now here again, we're asked to determine the amplitude. The constant in front of the sine is -3. So we take the absolute value. So the amplitude is 3. And the amplitude is just the height of, I should say the distance from the x-axis to the point farthest away from the x-axis. Here we're asked to determine the period. So again, you're going to take 2 pi because that's the original period for your sine function. But notice we have a constant 3 in front of the x. So you're going to take 2 pi divided by 3 to get the new period. Here, the constant in front of x is 1/3. You're going to take 2 pi divided by 1/3. When you divide by a fraction, you multiply by the reciprocal. And the reciprocal of 1/3 is 3. So this is going to be 2 pi times 3, which is 6 pi. Here says determine the period of y equals 3 sine 7x minus pi over 2. Don't worry about this constant here. This is just the phase shift. And we are looking for the period. So you take 2 pi and divide it by the constant in front of the x. So that's 2 pi over 7. And I'm just going to check. Looks like everything's working okay on my Zoom. Just kind of get a little nervous. You just spend all this time recording and then you're wondering if you're, if you're muted or something strange like that. So I just wanted to check real quick. Okay, in this question, we are asked to find the phase shift of the function. And the phase shift is found by taking this constant here. And you're actually going to take the opposite sign. So it's going to be minus pi divided by the b, which is the constant in front of the x. So you're going to take negative pi over 5. And when it's negative like that, that means it's going to the left. So whenever this is positive, you shift to the left. And whenever this sign here would be negative, you shift to the right. So since it's positive, we're going to do pi over 5 to the left. The 1/2 does not affect the period, or I'm sorry, the phase shift. Here we're going to determine the phase shift of y equals 2 sine 1/2 x minus pi over 2. And so again, you're looking at this constant right here. It's negative, so our shift is going to be to the right. And you take pi over 2 and divide it by 1/2. So that's going to be the same as multiplying pi over 2 by 2. The 2's are going to cancel, and it's going to be pi units to the right. So D is the correct choice. Okay, graphing the function here. Notice that there's a phase shift. The period is not going to change. It's 2 pi, but it's shifted to the right pi over 3 units. And the amplitude is 2. So let's take a look at some of these graphs. I'll start with A. This one looks like it has a period of 2 pi, but this looks like a cosine graph that's been shifted. The shift is, let's see, what was the shift? It was pi over 3, so that's 1/3. Let me think. This is 2 pi, so here's pi, and so 1/3 of that is going to be 1 hatch mark. And this looks like this is definitely not the graph because that's a cosine. Let's take a look at this one. This one looks like it looks like the same period and the same shift, but notice the amplitude is only 1. The amplitude on this one hasn't changed. So we have to have an amplitude of 2. So these all have an amplitude. These two have an amplitude of 1, it looks like. So those are out. This one, notice that normally the sine function would start here, but it's been shifted 1/3 of pi over, so that's good. It goes up and then comes back down, and the amplitude is 2. This is the correct graph. Okay, now we've got an amplitude of 2, but this negative sign here means it's been reflected across the x-axis. So instead of going up like a classical sine wave, it's going to go down initially. And the period is 2 pi divided by 4 pi. That's 1/2. So your period is going to be 1/2. So let's see. Let's just start looking at some of these graphs. It looks like we have a period here of 1/2. So this is 2. This looks like it's about 1. It looks like the period's right on this one. It's been shifted to the right 3/4 pi units. So that's going to be about 1/4. So let me take a look at this again. And the negative means it's going to go down. So this one definitely goes down, and it's been shifted to the right. This looks like the right graph, and the period or the amplitude is 2 because it has a height of 2. I think this one is it, because you'll notice that it would normally, the sine wave would, this point would normally be at the origin, but because of the shift, it's over here. And since it's negative, it's a reflection across the x-axis. So it's going to go down, up, and then back down. And that period is about 1/2. So this looks like the correct graph. Let me just make sure. This one has not been shifted to the right at all. So this one is out. And this one, the period is wrong. This one has not been reflected or shifted. This is just a classical sine wave with an amplitude of 2 and a period of 1/2. So it's definitely A. Oh, I guess I'm wrong on that one. I'm going to come back to this one and do this in class. This is number 21. I need a piece of paper and a pencil to demonstrate this and do this right. So I'm going to come back to 21 in my next video when I record this at my 9:30 class. I'm recording this one at home and I don't have a doc cam, so I can't draw this out. I'm not sure what I did wrong there, so I'll have to come back to 21. 22. All right. The amplitude is 1/4. So you can see that choices B and D are not going to be working because the amplitude is 1. And so it's either going to be A or C. And the period is 2 pi divided by 1. Okay, so the period hasn't changed because this constant in front of the x is 1. So the period is 2 pi, and it's a sine function, but it's been shifted to the right by pi. So it looks like A is the correct choice. Here, the period is 2 pi, and it's been shifted to the left. Now, this actually looks like the right one. Yeah, this one's not right because the period here is only pi. Yeah, that one's out. So definitely C is the correct choice. Let's look at this. Here's the sine wave. Goes up and then back down. And you can see the height is at about 1/4, which is where it should be. And it has been shifted to, if you think about it, it's been shifted to the left pi units. Is that right? Yes, the plus sign means it's going to be shifted to the left. So C is the correct choice. All right. It says determine the period of y equals cosine 5x. The period is 2 pi divided by the b constant, which is in front of the x. And that would be C, 2 pi divided by 5. Determine the period of 3/4 cosine minus 4 pi over 5x. Okay, so the period is 2 pi for cosine, and we're going to divide by this constant here. So that's going to be 2 pi multiplied by an negative 5 over 4 pi. So that's going to be, and by the way, this negative is not going to affect the period because all it does is reflect across the y-axis since it's inside the parentheses here. So we really don't have to worry about the negative sign. We're just going to take 2 pi and multiply it by 5 over 4 pi. The pi's are going to cancel, and you're going to have 10 over 4, because you're multiplying by 5, the 2 pi by 5, dividing by the pi, and then so 10 divided by 4 reduces as 5/2, and that would be B then. Okay, we're determining the period. Again, the period of cosine is 2 pi. So the new period, we're going to divide by this constant in front of the x, 2 pi divided by 5. Here it says determine the phase shift of the function. The phase shift is the opposite. So this is a plus, so that means it's going to be to the left, and you're going to take pi over 8. And that you take this constant and divide it by the constant in front of the x. So pi divided by 8, and because this is plus, it's going to be to the left. Okay, here we have the phase shift is what we're looking for. Now this negative is going to come into play here, okay? Because normally you would have the negative distributed through, and so when we pull this negative out, when we factor the negative out, it's going to be plus pi over 3. So that's going to be to the left, and we're dividing by this constant in front. So it's going to be pi divided by 6, because you have pi over 3, negative pi over 3 divided by negative 2 is going to be pi over 6. And since it's positive, it's going to be to the left. Here, we're asked to graph the function. So first, you're going to notice that the amplitude is 1/3. And it's the cosine function, which is shaped like a vase, kind of, but it's been reflected because of this negative here, reflected across the x-axis. So it's going to be kind of an upside down vase, if you will. Here we have a sine function. D's out because this is the sine, okay? There's been no phase shift, so we don't have to worry about that. The period is 2 pi divided by pi over 3, which is going to be 2 pi times 3 over pi. The pi's cancel, and so your period is 6. And in each picture here, you'll see that the one single wave goes to 6. So that looks good. And like I said, it's going to be an upside down vase shape, and it looks like C is the correct choice. As you can see, here's the upside down vase shape right there for cosine. So that is the correct choice. So for number 29, the amplitude is 2/3. That's the constant in front of the trig function there. And it looks like all the graphs, well, this one looks like it has an amplitude of 1. So that's out. D also looks like it has an amplitude of 1. So that's out. Again, the amplitude is just the height of the function, or the distance from the x-axis to the maximum point, also the distance from the x-axis to the minimum point. That distance, which is going to be positive, because distance is always positive, is your amplitude. So this one is 1, C is 1. These two are out. We're looking for an amplitude of 2/3. Yes, this has an amplitude of 2/3. And this has an amplitude of 2/3. But notice that A and B have different periods, okay? So it looks like the period of this one here is 2 pi. And notice that if you take your period of cosine and divide out by this constant 2, the new period is 2 pi divided by 2. So that's going to be pi. And that is exactly what we have here. We have one complete wave. And this point right here is halfway between 0 and 2 pi. So that is pi. So this one has a period of pi, which agrees with the function here. So you don't necessarily have to graph the entire function when you do these problems. You just need to eliminate the other 3. And so that's what I did on this problem. All right, now we're doing the reverse of what we have been doing. Instead of finding the equation, we're given the graph. I'm sorry, instead of finding the graph from the equation, we're given the graph to find the equation. So let's take a look at this function here. Notice it has a vase shape. That's the cosine function right here. It starts at an amplitude of 4, comes down and goes down to -4. So the amplitude is obviously 4. It's the cosine function, and the period is 6 pi. So that means you've divided out by 1/3 to calculate the new period. You had 2 pi divided by 1/3 is 2 pi times the reciprocal of 1/3, which is 3, and 2 pi times 3 is 6 pi. So our B constant is 1/3. And so here you can see an amplitude of 4, and the V shape is the cosine function, and here the B value is 1/3. All right, so now you can see that the period is much shorter. We have gone through 3 cycles. Let me pop this out here. First of all, notice it passes through the origin. So this is the sine function. We have one complete cycle, then another, and then another to get to 2 pi. That means there are 3 periods, 3 times as many periods from 0 to 2 pi. So that means you're going to take your B value is 3, and your amplitude is 2. Right? This height is 2, so that's the amplitude. So it's 2, and then B is 3. So this is the correct choice right here. Here we have an amplitude of 2. Is this the same one? It may have just been accidentally put in there twice. It looks like the same problem that I just did. Yeah, I think it is. I just somehow got it in there twice. So I'm going to skip that one since I just did it. And here again, we have that cosine vase shape there. The amplitude is 5, and it looks like the period is 6, which means we took 2 pi and divided it by pi over 3, or the pi over 3 right here. So there is the correct choice. All right, now we're moving on to the inverse functions. And the way you're going to do these, notice it says exact value. That means you should not use your calculator if it's going to give you a rounded answer. Now, some calculators will go ahead and give you the right, put it in fraction form. And I don't know if you have a calculator like that, but if you don't, this is how you would do it. You use the unit circle. So I'm going to go ahead and share my screen and bring up the unit circle. I guess I'm already sharing my screen, but I'm gonna, let me double check. It says screen sharing paused. So let me fix that. Okay, there we go. This is unit circle in Embedded Math is the website that I use to get this. And you will have this for the test. Originally, I was going to say you had to print it out, but actually you don't, because I'm going to go ahead and attach it to the back of the test along with the formulas that you need. So here's the unit circle. So I think it was negative, sine of negative square root of 3 over 2, I think is what the problem was. So when you're doing inverses, so normally when you have a trig function, your input is an angle and your output is one of these coordinates. So for example, if you take sine of 30 degrees, here's your angle, and sine refers on the unit circle to the y coordinate at the angle. So here's 30 degrees. The y coordinate is right here is 1/2. So you're going to go ahead and sine of 30 degrees is 1/2. Well, when you're doing sine inverse, you're going to do the reverse. Your input is one of these coordinates, and then your output is going to be the angle. Now, it's very important to remember that the range, that's the output for sine inverse, has been restricted because in order to create sine inverse, you have to have a one-to-one function, and sine is not one-to-one. So we had to restrict the domain. Well, now that we restricted the domain, remember, because when you're finding an inverse function, you swap x and y. So the domain, which has been restricted, has now become the range for sine inverse. So the range is from, for sine function, is from down here. Now, it's not 3 pi over 2, it's minus pi over 2, because if you rotate in the negative direction, this angle down here is minus pi over 2, all the way up to pi over 2. So this right-hand side of the unit circle is where you're looking, okay? So we are looking for y equal to negative square root of 3 over 2. And you can see on the unit circle, this is 5 pi over 3, but you don't want to think of it that way. You want to think of the negative angle. So this is, if you come around here 300 degrees, you only got 60 more degrees to go to get to 360. So if you're going in the negative direction, from this point at 0 to this point is negative 60. So that is going to be the answer. The angle at this spot where y is negative square root of 3 over 2, and remember the sign of the angle is the y coordinate. Now we're looking for the angle that has this y coordinate. Negative square root of 3 over 2 is here at negative 60, which is coterminal with 300. So going back to the assignment. Oh, I said negative. I thought I had remembered it as being negative. So it's not, it's actually positive square root of 3 over 2. So let's take a look at that again. Here, instead of looking down here at the negative square root of 3 over 2, we're going to look at the y coordinate of square root of 3 over 2 in the first quadrant. So that would be 60 degrees at that angle. And remember, this is your input, square root of 3 over 2 for sine inverse, and your output is the angle at that coordinate. Okay, so 60 degrees is the answer. Which is pi over 3 in radians. Looks like I'm getting a phone call. Sorry, I'm a little distracted. Just let it ring, I guess. Okay. Now we're looking for the sine inverse, the angle that has an output for sine of negative 1/2.
Hi. Hello. Hello.
I don't know who that is. Don't recognize the voice. Anyway. Oh, I think they answered the phone at the base. Oh, hold on. I'm sorry for the interruption, folks. Mom? Oh, I don't know how that got answered, but I'm in the middle of a Zoom session. I'm gonna have to call you back.
Okay, bye.
All right, bye. Okay, so we go to the unit circle. And we're looking for y coordinate of -1/2 that is on this side. And so it's -1/2 is right here for y coordinate. And remember, this angle 11 pi over 6 is the coterminal angle, and we want to find the negative value. So if you come down this distance here, which is from 60 to 30, that's going to be pi over 6, but negative pi over 6. So we're rotating this way. So the answer is negative pi over 6. This is a quadrantal angle. Whenever you have the y coordinate equal to 1, that is right here on the unit circle. That is here at the top. So that's pi over 2 is the angle that gives you a y coordinate of 1. Okay, so the last few problems that I did, we were working with sine inverse. And so I was looking at the y coordinate. When you're working with cosine inverse, you are going to be looking at the x coordinate. And also, cosine has a different range than sine. So the cosine inverse function has a range from 0 to pi. So we're going to be looking in the first and second quadrants instead of the first and fourth quadrants like we did for sine. Okay, so we're looking for the x coordinate now of -√2/2 in the first or second quadrant. And because it's negative, it's obviously going to be in the second quadrant. So let's go to the unit circle and take a look there. Hold on, let me try that again. Okay, here we are, -√2/2, and this is the x coordinate. We are at an angle of 3 pi over 4, and that is exactly the angle we want because we're going from 0 to pi, so it falls in the right range there. 3 pi over 4 is our output for cosine inverse. Okay, we're still working with cosine inverse. Now we're looking for the x coordinate equal to 1. That is on the x-axis. If you look at the unit circle, here's x coordinate of 1. So the angle is 0 because the range is from 0 to pi. So that's your 0 angle there. All right, find the exact value of the expression tangent inverse of 1. All right, so how are we going to find tangent? When you're looking for tangent on the unit circle, you are going to take the y coordinate and divide it by the x coordinate. In order for that to equal 1, both the x and y coordinates must be equal. And then, so you're taking the same number and dividing by itself to get 1. So let's go. Oh, and also tangent, the range for tangent is the same, or tangent inverse, I should say, is the same as sine inverse, -pi over 2 to pi over 2. So going back to the unit circle, down here is negative pi over 2, which is coterminal with 3 pi over 2. And we are looking for two x and y coordinates that are equal. So right here, x and y are equal, and that is at the angle pi over 4. So C is the correct choice. All right, now, the only way that we're going to get 0 is if y is 0 and x is 1 on the unit circle. So when y is 0, that is on the x-axis. And the reason why you'll say, well, what about over at pi? Well, remember, pi is outside of the range. The range has to be from negative pi over 2 to pi over 2. So if you look at the unit circle here down at negative pi over 2, as you go around, the only way that you can get tangent equaling to 0 is if y is 0 and x is 1. So that angle is at 0. All right, now we're going to use a calculator to find the value of the expression in radians rounded to 2 decimal places. Okay, so we're looking for tangent inverse of 1.2, and notice it's in radians. So I'm going to go ahead and bring up my calculator. And we're doing tangent inverse, but before I start, make sure that you select radians for your mode. Tangent inverse of 1.2, if I remember correctly. And another word for tangent inverse is arctan. So that if I round it, it's going to be 0.88. Okay. Now we're going to use a calculator to find the value of sine inverse of negative 3/7, rounded to 2 decimal places. So I'm still in radians, sine inverse of, and this calculator, I have to put in 3 and then change the sign like that, divided by 7. And we get negative, if I round it, negative 0.39. And for some reason, that is not right. Let me try that again. Don't know what I did wrong. Oh, I didn't delete my problem from the previous one. Okay, sine inverse, 3 divided by 7, change the sign, and we get negative 0.44. Okay, use a calculator, same thing, sine inverse of 0.6. It's pretty much the same thing, so I'm just going to go ahead and let you guys do that one. All right, let's do this one. Sine inverse of square root of 6 over 3. So clear out my calculator. Sine inverse of square root of 6. Now be careful here. I intentionally did this one. I need to close the parentheses on the square root because I want to take the square root of 6 and divide the whole thing by 3. If I take this, if I didn't do that, I would have gotten the square root of 2 because 6 divided by 3 is 2. So I need to close the parentheses and then divide by 3. And then we get 0.96. Okay. Use a calculator. So this is kind of similar to the one I just did, except instead of sine, you got cosine. I'll let you do that one. Practice those. Just remember to keep your calculator in radians. All right, let's take a look at these now. We want to find the exact value of the expression. If possible, do not use a calculator. Okay, so normally when you take tangent inverse of tangent, you've got, they sort of cancel each other out, but there's the problem that tangent inverse is not really the inverse of tangent, it's the inverse of that tangent that we created by restricting the domain. And so you've got to make sure that your angle is in the right range when you're doing this. So the range for tangent inverse is from minus pi over 2 to pi over 2. And so we're looking in the first and second quadrants. And this particular angle, 5 pi over 7, I'm sorry, I said first and second. Sorry about all the noise. It's just, if you don't know, I have a large family. I have 9 children, so it's crazy here all the time. So very sorry about that. But anyway, I misspoke. We're looking in the first and fourth quadrants. And this 5 pi over 7 is actually in the second quadrant. So it's not where we want it to be. So the answer in this particular example is not 5 pi over 7. But if we think about it, 5 pi over 7, the period of tangent is pi. And so if you want 5 pi over 7, just look on the opposite side from the second quadrant, be looking in the fourth quadrant. And I'm just going to pull up the unit circle here. Just give me a second. I think it's, where is it? Right here. Okay, let's make sure you can see that. Yes. All right. So 5 pi over 7 is like, this is not really, this is 5 pi over 6, but 5 pi over 7 is close to it. 7 pi over 7 would be here. And then 3.5 pi over 7 would be here. So we know 5 pi over 7 is in between here. So the other one is going to be over on this side. And in order to get the angle rotation to the x-axis, you have to go 2 pi over 7. If you're at 5 pi over 7, you're going to rotate 2 pi over 7 to get to the x-axis. So over here, you're going to rotate negative 2 pi over 7 to get to the angle that we want. So that is the correct angle. I really should be doing these on paper. I think I'm just going to stop here for recording and then pick up in class tomorrow at, when I do this at 9:30. And that way I can draw this out. It's really hard when I don't have a doc cam to do this. So I think that's what I'm going to do. I'm going to stop here. And I would have been recording this in the classroom, but you know, they're shutting down the university at 1. So that's why I'm doing this at home. Okay, let me just go through here real quick and see. We've gotten through more than half, and so I should be able to do the rest of this. Let's see here. Let's look at this one here. Notice that pi over 2 is smack dab between 0 and pi, and that is the range for cosine inverse. So for this particular problem, the answer is just pi over 2. We can say that, yeah, they go ahead and cancel each other out, and that is the right answer. So that's nice when you have that situation. Negative pi over 4 is not in the range for cosine. And if we go to the unit circle here, here is negative pi over 4 at this spot. And cosine is square root of 2 over 2. And so if you want to look at the corresponding angle for cosine, you're going to be at this x coordinate square root of 2 over 2. So you're going to be in the first quadrant at pi over 4. So that is the correct choice there. Okay. This one's a little different because in the previous problem, we had cosine inverse on the outside and cosine on the inside. Here we have the reverse, cosine inverse. So the first thing you have to check is make sure that your input is in the domain for cosine inverse. And the domain is the range. The domain of cosine inverse is the range of cosine. The range is the output. The cosine function ranges from -1 to 1 as an output. So that is going to be the input for cosine inverse. And yes, 0.5 is in that -1 to 1. So when you take cosine of cosine inverse 0.5, you don't have to worry about it being out of the range. Now you're going to just have to check what angle are you going to be getting, and that's going to be in the right. Yeah, everything's good. You don't have to worry about that issue. You just have to check the initial input there. I had to think for a minute about that. Okay, this I'm definitely going to have to do on paper. So I am going to pick up at my 9:30 class tomorrow, and I'm going to post both of these videos for you to study with. And if you have any questions, just send me an email. I'd be happy to help you with any problems that you might be having or that you encounter as you're studying. Okay, so I'm signing off now.